Thus, the Powercuff
Cough.
girls were born, using their ultra super...
So our project is based on Conway's Game of Life, except with a hexagonal grid representation. The classic game is made up of 2D orthogonal square cells. Each of these cells has two possible states, dead or alive. These states are determined based on the state of neighboring cells. Our version of the game is made up of a 2D grid of hexagons that has 6 neighboring cells instead of 8. The rules occurring at each time step are as followed. 1. Any live cell with 3 or 5 live neighbors remain alive. 2. Any dead cell with exactly 2 live neighbors becomes alive. 3. Any live cell with 0, 1, 4, or 6 live neighbors dies.
Our grid is made up of Cartesian coordinates to represent the hexagonal cells. This means that each odd row is shifted a half of space to the right, and each cell has 3 coordinates, the first one being a Boolean to tell whether or not it's alive or dead, and the second 2 to represent its location in the grid. While there's a limited number of structures that we can create with the hexagonal format, we did manage to create a glider that moves forward about one space every 5 iterations, and there are quite a few oscillators that we were able to create that never stop.
The user interface that we've created for this program has a default setting where there are 2 gliders on a collision course, as well as some additional oscillators for the user to look at. The interactive functions for this interface, you would click a cell to either bring it to life or to kill the cell, and then press the spacebar to start the simulation. At that point, you can then actively click around the domain to adjust the cells during the simulation.